The Sun, our magnificent star, sits at the center of our solar system, a colossal furnace of nuclear fusion. It continuously pours out an immense stream of energy, a significant portion of which is light. This light, composed of tiny particles called photons, embarks on an incredible journey across the vast, cold emptiness of space. This journey is not just a simple trip, it is fundamental to life on our planet, the Earth. Without this constant stream of solar energy, our world would be a frozen, lifeless rock. The light warms our atmosphere, drives our weather patterns, and crucially, powers photosynthesis, the very base of the food chain. We often bask in its warmth without a second thought for its epic voyage. This voyage from the Sun to the Earth is not instantaneous, at least not from our perspective here on the ground. Light, though incredibly fast, has a finite speed. It travels at approximately 300,000 kilometers every second, a speed so immense it's difficult to truly comprehend. Yet, the distance between the Sun and Earth is also vast, about 150 million kilometers. So, if you do the simple calculation, you find that it takes sunlight roughly 8 minutes and 20 seconds to complete its journey and reach our planet. This means that when we gaze up at the Sun, safely of course, we are not seeing it as it is right now, but as it was over 8 minutes in the past. It's a small but significant delay, a constant reminder of the cosmic distances involved. Herein lies a fascinating paradox, one that challenges our everyday understanding of time and space. For us, the observers on Earth, the photon's journey takes those crucial 8 minutes. We can measure this duration, it's a tangible period. However, for the photon itself, the experience is entirely different. According to Albert Einstein's theory of special relativity, something extraordinary happens to time as an object approaches the speed of light. For the photon, traveling precisely at the speed of light, time effectively ceases to exist. From the photon's perspective, its creation at the Sun and its arrival at Earth, or anywhere else for that matter, happen at the exact same instant. No time passes for it at all. This mind-bending concept stems directly from Einstein's revolutionary insights into the nature of space and time. His theories revealed that time is not absolute and constant for everyone, but is relative, depending on an observer's speed. As an object accelerates closer and closer to light speed, time slows down dramatically for that object relative to a stationary observer. For a photon, which inherently travels at light speed, this time dilation is complete, time stops. It experiences no duration, no ticking clock, no sense of a journey undertaken. Its entire existence, from emission to absorption, is instantaneous in its own reference frame, a truly bizarre and wonderful aspect of our universe's physical laws. Light is so much more than just the visible illumination that allows us to see our surroundings or the energy that warms our skin. It is a fundamental force of nature, a carrier of energy and information across the cosmos. But what if its role is even more profound, more mysterious than we currently grasp? Consider the possibility that light acts as a kind of cosmic courier, a messenger that not only travels through the space we know, but perhaps interacts with layers of reality hidden from our direct perception. It bathes every corner of the universe, interacting with matter and energy in countless ways. Could it be silently gathering data, collecting impressions from its endless travels through the vast cosmic expanse? Our current understanding of the universe suggests the possibility of more than the 3 spatial dimensions: length, width, height, and one time dimension that we experience directly. Theories like string theory and M-theory propose the existence of additional hidden spatial dimensions, curled up so tightly that they are imperceptible to us in our everyday lives. What if light, being such a fundamental entity, has a unique relationship with these higher dimensions? Perhaps photons can take shortcuts through these extra dimensions or perceive aspects of the universe's fabric that are completely invisible to us. This idea transforms light from a simple wave or particle into a potential interdimensional traveler, exploring realms beyond our comprehension. If light can indeed traverse or interact with these other dimensions, imagine the kind of information it might carry. It could bear imprints of realities governed by different physical laws, or subtle clues about the ultimate structure of the cosmos. Perhaps the light that reaches us from distant stars and galaxies is not just a messenger from the past, but also a whisper from these unseen realms. We do not yet possess the tools or the understanding to decode such potential interdimensional information, even if it were embedded in the light all around us. Yet, the thought that the familiar sunlight might be subtly modulated by journeys through higher dimensions is a truly captivating prospect for scientific exploration. Think of the universe as an immense interconnected tapestry, woven from threads of energy, matter, space, and time. Light is undeniably one of the most crucial threads in this cosmic fabric. It doesn't just connect distant celestial objects within our observable universe, it might also bridge gaps between different layers or aspects of existence itself. Its journey is not merely a straight line across the void, but potentially a far more complex path, weaving through the very structure of reality. This elevates light from a mere physical phenomenon to a key player in the grand unfolding story of the cosmos, hinting at a universe far richer and more complex than our current senses can reveal. Our human perception of time is profoundly linear and unidirectional. We experience it as a river, flowing inexorably from a fixed past, through an ever-fleeting present, and into an unknown future. This intuitive understanding of time has served us well, allowing us to navigate our lives, plan, and build societies. However, modern physics, particularly Einstein's theories of relativity, paints a much more complex and less intuitive picture of time. It suggests that time is not an absolute universal clock ticking at the same rate for everyone and everything. Instead, time is malleable, stretchable, and intertwined with space in a unified fabric known as space-time. Our everyday experience of time is just one limited perspective on this deeper reality. Given that a photon experiences no passage of time during its journey, its perception of time, if we can even use that word, must be utterly alien to our own. While we are carried along by time's current, a photon exists in a sense outside of it. What if light doesn't experience time sequentially, moment by moment as we do? Perhaps from its unique vantage point, light perceives the entirety of time's landscape simultaneously. Imagine being able to see the entire span of a river, from its source to its delta all at once, rather than just the small section flowing past you. This is a challenging concept for our minds, which are so deeply conditioned by the sequential flow of moments. When we observe the cosmos, we are, in a very real sense, looking back through time. The light from the Andromeda galaxy, our nearest major galactic neighbor, takes over 2.5 million years to reach us. So we see Andromeda not as it is today, but as it was millions of years ago. Light from more distant galaxies can take billions of years for its journey. These breathtaking cosmic visuals, the swirling colors of nebulae where stars are born, the majestic spiral arms of ancient galaxies, the faint afterglow of the Big Bang itself, the cosmic microwave background, are all snapshots delivered to us by light, our tireless time traveler. Light acts as our historical record of the universe. If we could somehow adopt light's perspective on time, reality might appear incredibly surreal. Instead of a linear progression, time might manifest as a vast, static landscape, where all events, past, present, and future, coexist. Or perhaps it would be a dynamic multidimensional ocean, with complex currents and patterns far beyond our current imagining. Artists often attempt to capture such altered perceptions of time through surreal imagery, clocks melting and dripping like liquid, events looping back on themselves, or multiple timelines intertwining. These artistic visions hint at the possibility that our rigid, clockwork understanding of time is merely a convenient illusion, masking a far more fluid and mysterious reality with which light has a unique rapport. To understand our limitations in comprehending concepts like light's timelessness or extra dimensions, consider a simple metaphor: the ant and the truck. Imagine an ant living its life on a vast, flat expanse of concrete. Its world is essentially two-dimensional. It perceives length and width, scurrying about in search of crumbs, avoiding obstacles like pebbles. One day a massive 10-ton truck rumbles past, its giant tire casting a momentary shadow and causing a slight tremor in the ant's world. The ant might sense these disturbances, a fleeting darkness or a vibration, but can it truly comprehend the truck? Can it conceive of its three-dimensional immensity, its powerful engine, the driver inside, or the vast network of roads and cities it navigates? We humans, for all our intelligence and technological advancement, are in a somewhat similar position to that ant when we contemplate the deepest mysteries of the cosmos. We are well adapted to perceiving three spatial dimensions and a single forward-flowing dimension of time. Our senses, and even our most sophisticated scientific instruments, are primarily tuned to this limited slice of reality. When theories in physics suggest the existence of perhaps 10 or 11 dimensions, or propose that light experiences no time, we struggle to grasp these ideas intuitively. We are attempting to understand the truck of the entire universe with the perceptual tools of an ant, which makes the quest both challenging and incredibly humbling. Light itself remains one of the most profound enigmas. It is so familiar, so integral to our daily lives that we often take it for granted. Science has unveiled many of its secrets. We know its speed is constant and the ultimate speed limit. We understand its dual nature as both a wave and a particle, the photon, and we harness its energy in countless ways. Yet its most fundamental nature, especially its peculiar relationship with time and its potential interactions with other dimensions or hidden aspects of reality, continues to elude our complete understanding. Each new discovery about light seems to open up even deeper questions, pushing the frontiers of knowledge further into the unknown. Ultimately, the concepts of light, time, and dimensions are not isolated curiosities, but are deeply interwoven into the very fabric of existence. The photon's timeless journey across the universe is more than just a physical process. It's a powerful symbol of our own ongoing quest for knowledge and understanding. It reminds us that the universe is likely far stranger, more complex, and more magnificent than our current perceptions and theories can fully describe. As we continue to study light, we are not just investigating a physical phenomenon, we are peering into the heart of reality itself, seeking to unravel the deepest secrets of the cosmos, one photon, one discovery at a time.